Hello and welcome back to the Power Shed. Last video I did, I was kind of disgusted with that long way power supply, and I really didn't give justice to how to use a dynamic load tester. So I'm going to do this little test with one of my favorite little power supplies. So this is a 12 volt 10 amp LED power supply. It's not supposed to be laboratory grade like the other one, but 12 volts is and 10 amps is about what we tested the other one at. We went up to only like 5 amps, and the signal was kind of horrible. That power supply, I did some further testing on it, and it had a bad fine voltage pot. If you just touched it, the voltage would jump around. That's why I could never get it adjusted. And I was predisposed to thinking it was just a crappy power supply, because so many other people have said that it was difficult to adjust and that they've burnt out LEDs and other things because the thing would jump around a little bit. But I sent that back to Amazon for credit. I don't want another one. So we're going to test this one. Right now we got the scope set up, we got zero current, and I'm going to set up, see a few. So if I get to 2.5 amps, that's an average. And this is doing a 50% duty cycle, so that's the same as a 5 amp pulse. And now we're looking at this signal here, and let me stop it. What we see is the load comes on here, and as you can imagine, it immediately dips down and then recovers. Now what really isn't clear is this is a long gradual slope going down. And that's because we removed that 300 ohm resistor on the output. So this is slowly discharging the capacitors from a slight voltage overshoot. So the bottom is the current, and that's the equivalent of 5 amps up there. And all that other little noise and stuff, this shop has a lot of noise. Don't really think about that. But what you don't see is you don't see that sine wave that you saw on the long way. And probably the reason for that is this has 6,000 microfarads on the output to filter it. And I'm sure that the long way only has about 1,000 because the supply operates at a higher voltage. So let's get this back scanning. And I'm going to adjust this whole thing. So what I can do is you'll see it climbing up. What that does is it raises the baseline here. That bottom line would be 0, and so we're up probably about 1.5 amps, and we can bring it all the way up so these two waveforms are almost identical. So if we stop it, we can see that if there's just like an amp change in the power supply, that the voltage doesn't really change that much up there. But if we go back down to going from 0 amps up to full amps, there's a big change. And like I said, this long stretch here is the capacitors. They got hit with an overshoot of voltage when the load disappeared, and it's a slow discharge. If that 330 ohm was in there, or 300 ohm, whatever it was, if that was still there, you would have seen that much quicker drop to a flat position. So this power supply does pretty good. And that's basically how you test them. It's a kind of a neat little thing. This one is running at about 45 hertz and 50% duty cycle. So that's pretty slow, but it approaches line frequency, and that gives you an idea how the thing will perform with line variations too, a little bit. So that's my video, and I'd love to use this a lot more, but it takes up my whole bench. You know, I have less than 3 feet inside this shed, so it's really tough doing videos. But these power supplies, you know, they're normally about, I think, $12, $13 shipped. And if you can find them on auction, the last few I've gotten were under $10. And they're really nice. Like I said, you can change the resistors on them and bring them up to, you know, close to 14 volts for battery applications. And the fact that they will run off 60 volts DC is a real plus for a lot of solar systems. If you want to need a battery maintainer over the winter, or you have just some electronics you want to power, $9. So think about that, and thanks for watching.